Imagine you decide to learn Python and promise yourself 45 focused minutes every day. Monday goes well, Tuesday gets busy. By Friday, you are asking how long is one complete session? How much time am I really studying this week? And did I even finish today's session? That sounds like a small problem, but small, repeatable problems are exactly where programming becomes useful. In this lesson, we are going to build a study session planner from scratch. Along the way, you will learn how Python displays information, remembers values, understands different kinds of data, performs calculation, no magic, no memorizing random commands. Every concept will have a job in the program we're building. Here is our finish line. Four simple lines of output. The course name, the length of the study session, the total focus time for the week, and whether today's session is complete. Right now, this may look like a finished program, but by the end of the lesson, you will be able to explain every character that produced it, and you will know where the words came from, how Python calculated 55 and 225, and why false appears without quotation mark. More importantly, you will not just watch me build it. At the end, I will give you a short challenge to turn this into your own planner. So keep this in mind. Every new idea we learn will move one piece of it from mystery to something you can control. Before we write code, why start with Python? Because the same language can help automate repetitive work, power web applications, analyze data, build AI systems, and create small tools for everyday problems like this one. Python is popular with beginners because the syntax is readable, but beginner friendly doesn't mean limited. The ideas you learn today, values, data types, operations, are the same foundations used inside much larger systems. A program, however, is not useful if we can't see what it is doing. So our first step is simple. Let us make Python talk back to us. Make print one of the fastest ways to see what your code is doing. When Python reaches this line, it takes value inside the parenthesis and sends it to the screen. Let us read the line like a developer. Print is the name of the function. The parentheses hold the information we're giving that function. And the words hello. Pythons are surrounded by quotes, which tells Python their text. Python calls text like this is a string. When we run the line, the quotes do not appear in the output. They are instructions for Python, not part of the message itself. You can use single quotes or double quotes, but they must match. Open with one style and close with the same style. That tiny detail prevents one of the most common first-day errors. Code is written for two audiences. The computer needs exact information, but humans need context. That is what comments provide. A comment begins with a hash symbol. Python ignores everything after the symbol on the same line. So the comment doesn't change the result of the program. It simply explains why the next line exists. Here the comment tells us we're about to display the course name. The print line is the instruction Python actually runs. Good comments do not describe every obvious character. They help a future reader understand the purpose of the action. And remember that future readers might be you a week from now. Printing fixed text is useful, but our planner needs to remember information. That is the job of a variable. Think of a variable as a labeled container. The label course name points to the text, Python fundamentals. The label study minutes point to the number 45. Once those values have names, we can reuse them without type the original information again and again. Read an assignment from right to left, take the value on the right, and store it under the name on the left. In this context, the equal sign does not ask either two things are equal. It means assign this value to this name. Use clear lowercase names. Connect multiple words with underscore and do not place quotes around the variable name. A name like study minutes tells us what the value means before we even see the number. The word variable gives us a clue. The value can vary. At first, study minutes stores 45, so printing the variable displays 45. Later, we assign 60 to the same name. Python does not keep both values active under the name. The new assignment replaces the old one. Before I reveal the second result, predict it. If we print study minutes now, what should appear? 60. That's a date. It's called reassignment. It is what allows the program to respond when plans, scores, prices, or user choices change. Our label stays the same, but the information attached it can be updated. Variables remember values, but not every value behaves the same way. Python needs to know what kind of information it is handling. That category is called a data type. Today we need four: a string, stores text, an integer, stores a whole number, a float, stores a number with decimal point, and a boolean, stores one of two states, true or false. Python usually identifies the type from the value you assign. Quotes suggest text. A whole number without quotes become an integer. A decimal becomes a float. And the special words true and false become booleans. This may feel like labeling, but data types decides what operations are possible. Next example shows why two values that look almost identical can behave completely differently. A string is any text wrapped in matching quotes. It contains letters, space, digits, and punctuation. That is why both course name and the message on the screen are strings. Notice the word today's contained an apostrophe. Using double quotes around the full message lets that apostrophe sit safely inside the text. Now look at the most important comparison on this slide. Quote 45. Quote is a text. The number 45 without quote is numeric. They look similar to us, but Python treats them as different kinds of data. If we plan to calculate with a value, storing it as a text will create problem later. A useful habit is to ask, is this value meant to be read or it is meant to be calculated? Python gives us more than one numeric type. An integer represents a whole number, such as 45 study minutes. A float includes a decimal point, such as 0.75 hours. Neither values uses quotation marks because both are meant to behave like numbers. Let us test that behavior. What should Python print when it add 45 and 10? We get 55. Python performs the calculation first and then print displays the answer. That simple pattern calculates a value. store it if needed, and display the result. Some information is not text or a measurement. Sometimes the question has only two useful answers, yes or no, on or off, complete or incomplete. Python represents that kind of state with booleans. In your planner, completed today begins as false. Another program might track either a deadline exists with true. There are two rules remember. First, true and false begin with capital letters. Second, they do not use quotes. Put quotes around the true, it becomes ordinary text. Write true with a lowercase t and Python will not recognize it as a Boolean literal. Capital first letter, no quotes. That one pattern will save you from many beginner mistakes. What if you are unsure what type a value has? Don't guess, ask Python. The type function examines a value and report the category Python assigned to it. Here we pass each variable into type and then place that inside print so we can see the answer. Course name returns class string. Study minutes returns class integer. Study hours returns class float. And completed today returns class boolean. You do not need to worry about the word class yet. Focus on the final label, string, integer, float, and booleans. This function is especially useful when the code behaves differently than we expect. If math is failing, type can quickly reveal that a value you thought was a number is actually text. Now our stored numbers can start doing useful work. Operators are symbols that tell Python which calculation to perform. Plus adds, minus subtracts, the asterisk multiplies, and the forward slash divides. For one complete session, we add 10-minute break to 45 study minutes and get 55. For weekly focus time, we multiply 45 minutes by 5 days and get 225 minutes. Now, we divide 225 minutes by 60 to convert those minutes into hours. The result is there, 0.75. Here is a small but important detail. In Python, the forward slash returns a float, even when the division happens to be exact. So division naturally gives us a decimal style result. At this point, Python can remember our plan and calculate it. Text has its own useful operator behavior. The plus symbol does not always mean numerical addition. When both values are string, plus joins them end to end. We can combine the course name with the word session to create a clear label. The asterisk can repeat a string. Multiplying a hyphen by 24 creates simple divider without typing the same character 24 times. But types still matter. Python cannot directly add the string minutes to the integer 45 because joining text and performing arithmetic are different operations. For now, the simplest fix is to give print multiple values separated by commas. Print displays them together and add a space between them. Later, we will learn more flexible ways to format text and numbers. We now have every piece we need. Let us assemble them into one working program. I'm switching to VS Code and creating a new file named studyplanner.py. If you're following along, pause whenever you need more time to type. First, I will add a comment. Study Session Planner. It does not affect the program, but it tells us the purpose of this file. Next come the values of our planner. Needs to remember course name stores Python fundamentals as a string. Study minutes store 45 as an integer. Break minutes store 10. Days per week stores 5. And completed today stores the boolean false. Notice that the text has quotes, the number do not, and the false has a capital F with no quotes. These are visible in a way the values are written. Now we calculate total session equal study minutes plus break minutes. Python reads the current values, add 45 and 10, and stores 55 under the new name. Weekly focus equals study minutes multiplied by days per week. 45 times 5 gives us 225. Again, we store the result so we can use it later without repeating the calculation. Finally, we print 4 lines. First combines a fixed label with the course name variable. The second displays total session followed by the word minutes. The third displays weekly focus and the fourth shows our completion status. Let us run the program. There it is. Python fundamentals 55 minutes per session, 225 focus minutes per week, and false for today's status. This output is not hard-coded as one large message. It is assembled from stored values and calculated results. Change study minutes to 60 and run the program again, and both session length and weekly focus update automatically. That is the real power of variables. One change can follow through the rest of the program. Before the final challenge, let us debug 4 mistakes almost every beginner makes. Try to spot each problem before I reveal the correction. First, capital P in print. Python is case sensitive, so print and capital P print are different names, and the built-in function uses lowercase p. Second, a space inside study time. Variable names cannot contain spaces. Replace the space with an underscore. Study underscore time. Third, lowercase true. Python's Boolean literal begins with a capital T, so we write true with capital T. 4. Quotation marks. Around 45. That is not always wrong, depends on your intention. But if minute should be used in calculation, store 45 as a number without quotes. Errors are not proof that you are bad at programming, they're clues. Read the line carefully. Inspect capitalization, names, quotes, and types. Then test one correction at a time. Debugging is not separate from programming. It is part of programming. Now it is your turn. Pause the video and personalize the planner. Change the course name to a subject you are actually learning. Choose your own study and break times. Calculate your study time for 7 days. Set completed today to true and print every result. Do not worry about making it beautiful. Your goal is to make it run. Inspect the output and fix anything that does not match your intention. When it works, look at what you have accomplished. You use print to see result. comments to explain the purpose, variables to remember information, strings, integers, floats, and booleans to represent different kinds of values, type to inspect those values, and operators to turn raw information into useful answers. You didn't just memorize Python vocabulary, you used the vocabulary to solve a real problem. In the next lesson, we will make this planner interactive with input. Convert what the user types into correct data types and build a program that adapts to different people. If you want to keep building it with me, continue to the next lesson. And if your planner works, share your weekly focus result in the comments. I would love to see what you created.